Hello, hello. Hi, everyone. We're going to go ahead and get started with our group work video. Okay, so let's read the first one. It says find the area between x is equal to 2 square root of y and x is equal to y square root or square y square over 4. Okay, so it gives us the interval, but we want to double check this interval. So let's go ahead and write it out, and then we're going to go ahead and subtract. So we get y squared over 4 minus 2 square root of y is equal to 0. Okay, well, I don't like this 4, so I'm going to multiply everything by 4 to get rid of it. So I'll have y squared minus 8 square root of y is equal to 0. And then I'm going to go ahead and so I can make these multiplying, factor out the square root of y. So square root of y, and then this would be y, 3 over 2 minus 8 is equal to 0. Zero product property states that the square root of y is equal to 0, which implies y is equal to 0. And then the square root property states that y, 3 over 2 minus 8 is equal to 0. Y, 3 over 2 is equal to 8. Um, let's cube root this first. So if I do the cube root, I'll get y 1 over 2 is equal to 2. And then we know that this, the square root of what gives me 2, is 4. So the endpoints are the intersection points. So we have a little table that we can draw, and we should draw something for the middle because the two functions, x is equal to square root of, or 2 times square root of y, and x equal to y squared over 4 will equal. We're going to double check that though. When y is 0, x is 0. When y is 0, x is 0. When y is 4, that's going to be square root of 4 times 2, so 2 times 2. And then this is just 16 over 4 is 4. So let's pick a nice number in between. I'm gonna pick 1 because I know 1 is a square root and can be squared pretty simply. So when y is 1, x is 2, and when y is 1 here, x is 1 over 4. So that means this guy will be on top. So we have the integral from 0 to 4 of 2 square root of y minus y squared over 4 dy. And then we have 2y, the power of 3 over 3 over 2. And then minus, let's do it like this, 1 over 4, y to the power of 3 over 3, from 4 to 0. I'm going to simplify that first. That's going to be 2 times 2 over 3, y 3 over 2 minus y over 3 over 12. 4 and 0. That just becomes 4 over 3, y 3 over 2 minus y 3 over 12. We know for zeros that will just disappear, so reality we just have to worry about plugging in the 4. So I'm going to do 4 over 3 times 4, 3 over 2, minus 4 to the power of 3 over 12. Let me see. I'm going to rewrite this so I can mess with it better. I know I should do the square root first, or I could do square root first and then take it to the power of 3, so that's going to be 8. I'm pretty sure. And then the 4 to the power of 3. I believe that's 64, yes. Wait, and let me type in calculator. I'm pretty sure that's 64. Yeah, over 12, and then that's gonna be 2 to the power of 3 is 8. So 8 times 4 over 3 minus 64 over 12. I'm gonna simplify both of these a little bit. Let's start here. Um, 8 times 4 is 32, so 32 over 3. And then I'll divide both of these by 4. 64 divided by 4. Oh, 64 divided by 4 is 16 over 3. And then that means I'll have 16 over 3. That's my final answer. Let me double check my work. Very good. Don't forget, you only do 4. Okay, I'm gonna say this right now. You only do 4 because at 0, the whole thing will just be 0. So you just be doing a minus 0, which doesn't really matter. Okay. Next, find the area between y is equal to x squared plus 4x plus 6 and y is equal to x squared over 2 from x is equal to negative 6 to negative 2. Okay. So we have to do these. Let's go ahead and set them to equal. So we got x squared plus 4x plus 6 is equal to x squared over 2. I don't like the fraction, so I'm just going to go ahead and I could have done it here as well, but I'm going to go and multiply the whole thing by 2. So let's go ahead and do that. We got 2x squared plus 8x plus 6 is equal to x squared, and then we subtract an x squared. So we got x squared plus 8x plus 6 is equal to 0. From here, I could factor. Oh, I didn't multiply. I multiplied this by 2, but not. I was wondering why it looked a little off. 12. No, I don't know why I did that one. 12, 12. Wait, can I just do this? Nah. It ruins it into 2, apparently. Okay. 6. Okay, so what factors of 12 add up to 8? That's going to be 2 and 6. So x plus 2, x plus 6. Okay, so those are just the intercepts, I'm pretty sure. X is equal to negative. Yeah, those are going to be the intercepts. So now we just have to check in the middle of them. So you can start off with the lowest and the highest, but we need to pick something in the middle of these guys. I'm going to first just double check that they do actually line up at that value, though. And then we have x squared over 2. Okay. I'm just going to plug that into a calculator. We got 36 plus or minus, what is that, 24 and plus 6. That's going to be y is equal to 18. And over here we got 36 divided by 2, which is also 18. Yeah. And for negative 2, we have 4 minus 8 plus 6, which is 2. And then over here we got 4 divided by 2, which is also 2. So now we need to pick something in the middle. There's not really a best middle in my opinion. I'm just gonna go for a number that's the easiest to deal with, maybe negative 3. Because the higher we go with that number, it's gonna be a bit more messy. So for the left, that's a 9 minus 12 plus 6. Y is equal to 3. And then for this one, we got 9 over 2, which is 4.5. So that's on the table. So the integral should be set up with this guy first minus this whole thing. From -6 to -2. Okay. That could be simplified to 3 over 2x squared. No, not 3 over 2. Because 1/2 minus 1 is negative. I don't know why I added them. Wow. 1. And then minus 4x minus 6 dx. So we have -1 over 6 x to the power of 3 minus 2x squared, and then minus 6x for -2 and -6. And now we have the thing where that 0 doesn't, just disappear, right? So we should do 2 sets of these. For this one, the first batch is going to be a -8. So -8 in that space should be 8 over 6 because the negatives would cancel out. Here we have a 4. 4 times -2 is -8. And then -2 times -6 is +12. Then over here for the -6 for subtracting, we have -6 to the power of 3, which is negative 216, which I'm already going to go ahead and do that. Oh, I forgot the negative, but it's still the same thing. Divided by 6, and then the whole thing with that negative in the front. So it just becomes a positive 36. And then we have -2 times -6 squared, which is 36, so -72. And -6 times -6 is plus 36. Does this equal 0? That equals 0. That's so funny. Okay. Not that funny. It's not that funny. But you know what I mean. Okay. 8 over 6 plus 4. Simplify this. Actually, I'm going to simplify that. Both of those are divisible by 2. So 3 over 2 plus 4. Cross multiply, we got 3 plus 8 over 2. Cross multiply, butterfly method. We have 11 over 2 as our final answer. Okay. Let me just double check. Uh, I did this fraction completely wrong. I am tired. That's what I get for recording past my bedtime. Right. Yes, I'm an adult. I have a bedtime. All proper adults should have a bedtime. Sorry, that's not that funny. Whatever. Trying to humanize myself a little bit so y'all don't think I'm, just some math robot. Let's see. 3 and then 4. So 12 over 3. And that's the answer. No, because then we do 3 times 8, which is 12. And then that's going to be 16. Okay. Okay. All right. That's going to wrap up that one. Did you see any of that? Oh, I hope you all saw that. Okay, so just a recap. Blue is this value. Green is this value. This became 0 by literal happenstance. This is the one we had to further evaluate. I started with this first, and then I realized I've simplified incorrectly. So I divided by 2, and then I did butterfly, and I got this. 16 over 3. All right. Last problem. This is the one I told you about, where technically speaking, we have issues where we can mess with this a little bit. Okay. So let's go ahead and talk about it. All right. Find the area between sine of x and cosine of x on this interval. Okay, well, we know that this does, because of how they work, tend to overlap. So if we do the thing where we set them equal to each other, sine of x is equal to cosine of x, and you can go ahead and maybe even treat it like this, sine of x minus cosine of x is equal to 0. You can't really factor anything out, or you can't mess with this at all, truly, to where you can use the zero product property. But you know that there are points where they do have the same thing. And it's this pi over 4 angle, and then another half period when they're both negative. We can talk about it here. So let's go ahead and just fill this out, and you'll see what I mean. So when x is 0, this y will be 0, and this y will be 1. When x is pi over 6, this y will be 1 over 2, this y will be square root of 3 over 2. When pi is over 4, this is square root of 2 over 2, and this is square root of 2 over 2. When this is pi over 3, this is going to be square root of 3 over 2, and this one's going to be 1 over 2. And then when we have pi over 2, this y is 1, and this y is 0. So two things happened here. We did that thing I warned you about in the beginning of this lecture, of the lecture 2.1, where we didn't, we gave an interval that zooms in, but within that interval, they do cross. So we have an issue where from here to here, this is on, not top, this is on the bottom. And from here to here, this is on the top. And then from here to here, this guy's on top. And this guy's on the bottom. Well, how do you do that? Well, recall this integral property. We state that if we have, an integral where something is in the middle, such as c, that we can split it up like this. However, dx. So we're going to use this property to fully evaluate the difference between, or the area between these two guys. So we technically have two problems. The area in between this interval and the area in between this interval, and we combine them to be that interval. So we want the area from 0 to pi over 2 between these two functions. So I'm just going to write as an absolute value sine of x minus cosine of x. But in reality, we can split this up and make it to where the guy's on the top and the guy's on the bottom. So I'm going to split them up at the point pi over 4. At this point pi over 4, we see that cosine's on the top and sine's on the bottom. After pi over 4, and then we stop at pi over 2, this guy's on the top and cosine's on the bottom. And then we're just going to do these two intervals Separately, we have cosine, which is just sine of x, negative sine, which is just cosine of x, and pi over 4 from 0, and plus sine, which is negative cosine of x, and then negative cosine becomes a minus sine of x from pi over 2 to pi over 4. And we're going to go ahead and evaluate these separately with 4 sets of colors. Let's get that. I'll do a deep red and a yellow. Okay, let's go over here. So that's going to be sine of pi over 4 plus cosine of pi over 4. And that's going to be just 2 sets of square root of 2 over 2. So square root of 2 over 2 plus square root of 2 over 2, which is just square root of 2. And then we'll do 0 next. So minus sine of 0 plus cosine of 0. I don't know why I started it here. That's because I probably won't have enough room. Sine of 0 minus cosine of 0. So that's going to be sine of 0 is 0, and then cosine of 0 is 1. So that's just going to be a minus 1. So minus 1. And then we'll do this other integral result. We have plus in parentheses negative cosine of pi over 2 minus sine of pi over 2. Negative cosine of pi over 2 is going to be 0. And then, or negative 0, which is 0. And then negative sine of pi over 2 is negative 1. So we have plus a negative 1, which is just minus 1. Then this one in the deep red color, you should be able to see the difference. We're doing minus a negative cosine of pi over 4 minus sine pi over 4, which just comes out to negative square root of 2 over 2 minus square root of 2 over 2, which just comes out to a positive square root of 2, because that will combine to be negative square root of 2, and the double negative makes it positive. So then, our final answer comes out to the form, we have 2 square root of 2 minus 2, which I believe is a positive area, but just to be safe, I'm going to type that into a calculator. Yeah, for sure we get a positive area. Okay. All right. And that is going to be it. All right. Let me just double check my work. Split it up here. Signs at the top. Pi way to pi over 4, 0, we get square root 2 minus 1, and then let's see. And then yeah, okay. Just double checking that. Okay, and we're good. All right, that's gonna be our answer. Right. All right, let's move into now 2.2. Okay, 2.2 says find the volume of the solid generated by rotating the region between y is equal to this expression and y is equal to 0 around the x-axis. Okay, so that's interesting because that's just kind of finding the area. Well, I mean, we can still do it. It's not crazy. Okay, so the formula is the outermost by the innermost, which technically they've defined as like a line, right? So it's given the premise of a washer, but it's kind of just a disc, really, if it just has that one line in the middle. Here, make it a little bit bigger. Um, but I can see, its premise. I think I took this from one of your homework problems. So let's go ahead and just do that. We have, for the interval it's asking from -6 to 2, we have pi times the square of the outermost radius, which we can see here visually, is 2 square root of x plus 6 squared, and then minus the innermost radius, which is just 0 squared dx. Okay, that will just go away. This needs to get done. That's going to be 4, and then times x plus 6. We could definitely distribute that, or actually we could just take it out. I just do that. We have 4 pi 6 2 of x plus 6 dx. So that is going to be defined as x squared over 2 plus 6x from 2 to -2. Um, plug it in to be 2. Here, let me color code that. We have 4 over 2, which is 2, and then plus 12. And then for -6, minus 36 over 2, which is just 18. And then minus 36, so that'd be a -18 that comes out positive later. So we have 4 pi is equal to 14 plus 18, which is just 32 times 4, which is, I think it's going to be like 128. 14 plus 18 is indeed 32. And then 32 times 4 is 128. So 128 pi is our answer. Let me go ahead and check my worksheet. Yes. Okay, good. All right, next, find the volume of the solid generated by rotating the region between y is equal to -4 and y is equal to -x squared, or yeah, -x squared on -2 to 2 around y is equal to 2. Okay, so this one is a bit different because our center is here. So if this is the function y is equal to -x squared, its mirror about here would be us moving it up 2. So it would be, we start with y is equal to -x squared. We moved it up 2, so it can meet up here. And then we flipped it because, oh wait, actually, oh wait, but it's separated, so we don't move it up 2. We have to mirror it, so we know the mirror would start here because it's not directly on the x-axis, excuse me. So we actually moved it up 4, and then we flipped it to get this shape. and we flip it to get y is equal to x squared minus 4. Okay. Let me just see. Okay, moving it up. Mhm, mhm. And then we flip it on its x-axis. Hold on. Let's move this again. We got 1, 2, 3, 4. Oh, it was already negative. No, it's positive. So x squared, but it's because I know that x squared looks like this, and I bring it forward, do that there. But we start with moving it up, because, and then, or you could flip it first and then move it up, but that kind of ruins my visualization of it. Let me look at our old uh, one just so we can try to match the logic of what was said earlier. Okay, so for this, we started off by moving it 5 because the center was at 5. Mm, it starts here at 0. Oh, I made the mistake. Okay, so if we're to make this to where this is the center point, then technically this, if this is 0, that's -1, -2, our function becomes negative x squared minus 2. I was focusing too hard on this idea of moving it and flipping it. So that's on me. So I move it 1. So this gets shifted, 'cause it starts at 0, it gets shifted down to be 2. That's 1, 2. So we have it to where it's represented as y is equal to negative x squared minus 2. And then you flip it then, and it becomes y is equal to x squared plus 2. Yes. Okay, so now that definitely tracks. And then you're doing, it says about, so y is equal to 2, so it's an x-axis line. So you're still doing the washer, I mean the disk in this sort of way. So -2 to 2, and you this is all the outermost, because it says, okay, between y is equal to -4, so -4 is here. Okay, so then again they're giving us another line to do. So what's this guy? Well, we can technically just visualize what this guy is, but we should do it the hard way. If this is the outermost, no, this won't be the outermost. Yeah, I can already see visually that it's going to be the innermost. Let's still do it. This is the outermost. Here, let's focus on flipping this first. Let's flipping this first, then this. Oh, so it is a disk because Yeah, I ruined it by drawing the thing myself. That's going to be the hole, and then this would be the circle inside of that hole. And this would be the circle inside of that. Okay. Oh gosh. Sorry, I'm not even that. I like these problems. They're very fun, but you do have to do a lot of visualization. There's just no way around it. So this is the innermost. And now let's figure out what the actual function we should use for the outermost. If the outermost, we start off with y is equal to -4. You have technically shifted it. Let's do -3, -4, 5, -6. You shifted it down 2 because we moved this whole thing to where it's 2. So 1, 2. So y is equal to -4 minus 2, which is -6. And then you flip it. So it's y is equal to 6. And you can even see a 3, 4, 5, 6. Yes. Okay. All right. Outermost radius. So pi of the outermost radius, which is 6 squared, minus the innermost radius, which is x squared plus 2 squared dx. And then we can do this. We have pi outside, -2 to 2, 36 minus x squared minus 4x minus 4. That's going to become 32. So let me write it. I was going to skip this step, but let me just write it. -x squared minus 4x minus 32. No, plus 32. And then I'll write the whole box. Negative x to the power of 3 over 3. Negative 2x squared. And then plus 32x from 2 and -2. Okay. Uh, for 2, it's going to be -8 over 3 minus 8, and then plus 64. And then for -2, wait, I forgot to write this. It's minus -2, which is -8. So that'll become positive with a negative in front of it. So 8 over 3, -2 minus 8. And then -2 times this, which is -64. But then the negative will distribute to where this is a negative, that's a positive, and that's a positive. So this will just double, this will cancel out, and this will double. So we're left with -16 over 3 plus 12 8. We could butterfly method this to get -16 plus 128 times 3, which I'm not about to do in my head, because that's ludicrous. That's ludicrous with tile crews. Sorry, I don't know if you know that reference. Over 3. And then 384 minus 16 is 368 over 3. And then I'm just going to double check if that's divisible by 3, and it's not. So that would be your final answer. Let me just double check. Oh, I forgot the pi. I always forget the pi. Um, pi. Okay. All right. Uh, Mm. Oh, I made a mistake. Um, it's x squared plus 2. I thought it was x. That's no problem. We can definitely just revamp it. I'd rather we do it on a blank page though, but we don't have a blank page on me. Let me just revamp it with a blank page. Give me a second. Alright. Okay, so starting from here, we get pi. We get what is that? 36 minus x to the fourth plus 4x squared and then plus 4. Or no, I forgot the minus. Let's do it like that to be cheesy. And then from here, this can get simplified to negative x to the power 4 plus 4x squared. Then, sorry, it's minus. And then plus 32. Do the whole bounds again. Negative x to the power 5 over 5 minus 4 x to the power 3 over 3 and then plus 32x from 2 to negative 2. Okay, let's go from here. We got negative, or let me write the around parts. We got pi parentheses negative 32 over 5. And then this is also going to be 32. 32 over 3, because 4 times 8 is 32. And then uh, plus 64. And then over here, we got minus, parentheses, 2 to the power of 5 will be a negative 32. So we have a negative 32 over 5. And then we have similar vibe here where that's going to be 32 as well, but the negative exists. So we'll have a negative 32 over 3. And then we see that's going to be minus 64. One color. Now, this will triple negative, so that becomes a negative itself. I'll do it like that. That becomes a positive. Let me see. Negative, negative. That's a positive. So that's positive. And then negative, negative. That's a positive. Okay. So really, only these middle terms will cancel out. But we're left. Actually, let me do that again because I feel like that was accidentally. That might get accidentally confusing. Or just do a new line. So it was minus, 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 plus. No, minus as well. Everything had a minus. So it was minus, minus. That became minus organically, and then this had a negative in front of it. Okay. Uh, let's see. That distributes to a plus, and then that distributes to a negative. So then it's is gonna be negative 32 over 5 minus 32 over 3 plus 64 minus 32 over 5 minus 32 over 3, and then plus 64. Okay, now do I believe all this? Let me just check my solutions. I'm trying not to do that, but can't help it. Yeah, okay. So we can see here that all of this doubles. Um, let's just double it all together. So we got 2 times negative 32 over 5, negative 32 over 3 plus 64. Um, from here we can start off with um take out the negative, but then also just doing 32 times 3 plus 32 times 5 over 15, which is technically 32 times 8, which is another, it's going to be another 2 power number, but instead of figuring it out, I'm just going to type it. Let's see, 32 times 3 plus 32 times 5, 256, yeah. Negative 256 over 15 plus 64. Rewrite this. 64 times 15 minus 256 over 15. 15 minus 256. So 2 pi 704 over 15. And then we can rewrite this as 1408 pi over 15 as your final answer. All right, let's keep it going. We got one more example here. Find the solid generated by rotating the region between y is equal to negative, or y is equal to 2x and y is equal to x squared around y is equal to negative 2. Okay. So for this, we have y is equal to negative 2. So that means this is in our x origin problem. But we have to figure out when do they intersect. So that's also going to be a detail that we need to do. But this time we have the luxury of both of our functions being on the right side, so we don't have to worry too much about the rotation, but we should still be able to figure it out. So this is going to be our 0. We're basically moving everything down. No, I'm sorry. We are moving, so it'll be 1. If that's 0, so 2. So we moved it up 2. So we're moving everything up 2, so that means both of our radiuses, regardless of what they are in our outer. What the heck? Oh my gosh. I should pause the video right now and just leave it out. Sorry y'all. I am tired it seems. Hold on. Okay, it's U. Okay, maybe it wasn't that big deal. I don't know why I had to double check it. The radius for both of these is y is equal to 2x plus 2, and then y is equal to x squared plus 2. So just moving it up 2, okay. And then from here, I'm just double checking because if that's true, then this coordinate right here is going to be 0, 2, yeah, okay, cool. All right. And then we have to check out what points these guys intersect now. And we see that the top part will be the line, but we technically don't know that yet, so we still have to figure out when they intersect. So let's go ahead and do that. We have 2x plus 2 is equal to x squared plus 2. Put everything on one side, we get x squared, negative x squared, sorry, plus 2x, and then there's no 2's, they'll cancel out. Factor out the x, so we have negative x plus 2 is equal to 0. So we know they intersect when x is equal to 0, and when x is equal to, what's that, 2? Yeah. Which we can also see visually, but we don't know that yet. Okay. So now we need to make a table for when it's on the top and the bottom. Uh, 2x plus 2, x squared plus 2. We know when x is 0, this is going to be 2 and 2. And then when this is 2, that's going to be 8. No, it's going to be 6 because 2 times 2 plus 2. That's going to be 6. And that will also be 4 squared plus 2, 6, yeah. So let's pick a number inside. Let's just do 1. That's going to be 4. And then that's going to be 3, which we already knew visually that the line would be above, but we technically didn't know until we did it. So we pick the point 0 to 2, and then we do pi of, or I should wrote the pi in there, but I skipped that step, of the outermost, which this is the top, so 2x plus 2 squared, and then minus the innermost, which is this guy, which is x squared plus 2 squared dx. Okay. Let me just double check. All right. So let's go ahead and keep this out. That first guy is going to be 4x squared plus 8x plus 4. And then this guy is going to be minus x to the power 4 plus 4x squared and then plus 4. All with the negatives not distributed yet. So let's go ahead and subtract that. So that will be negative x to the power 4. That actually just cancels this out and cancels this out. So we left a negative x4 plus 8x dx. All right, now let's do the integral. Negative x to the power 5 over 5 plus 4x squared from 2 to 0. I'm going to take advantage of the 0 being used to get pi of negative 32 over 5 plus, what is this going to be? 4 squared 4 is 16. Then I'm going to go ahead and butterfly method those guys to get 16 times 5 minus 32 over 5. I believe I will still have a positive area, which is a good indication that you're doing this problem correctly. So you'll get pi times 48 over 5, which is 48 pi over 5. Okay. Checks. Okay, last one. And this one actually is just straightforward. Find the volume of the solid by rotating the region between x equal or y is equal to x squared plus 3 and y is equal to 0 on 0, 2 around the x-axis. So this is almost another trick question. I'm tempted to just change the storyline a little bit so it's more like the disc, but I already wrote it like this, and we need a break from all these. I'm thinking for all of these, what I should do, random sidebar. I'm thinking, what if I give you the answer for this? I have two options to ask you this question. Either one, I give you the answer and you just provide the solution. Like if I just gave you just this, what's the solution? Or what I could do is I could do the problem, be like, what mistake did I make? But I don't like that second one because we're still kind of just learning these. But I'm gonna brainstorm these. If you have any ideas, let me know. Or if you don't like my suggestions, let me know. Okay. Next, find the volume of the solid by rotating the region between this and this. Pi. Does it give us a bound? It gave us a bound. Okay, good. 0 to 2 of the outermost, which is clearly this. So x squared plus 3 squared minus 0 squared dx, which is just. I'm going to skip some of the simplifying. We have x to the power 4 plus 6x squared plus 9. And then dx. And then we have x to the power of 5 over 5 plus 2x to the power of 3 and then plus 9x for 2 and 0. I'm going to skip the part where I skip plug in 2 because I don't have to. I mean 0 because I don't have to. We have 32 over 5 plus 32. No, that's going to be 16. Excuse me. 16. Then 9 times that is 18. That's going to combine into. I'm not going to do that math out loud. I'm going to do that math out loud. I'm tired. 32 over 5 plus 34. I'm a butterfly method that to get 32 plus 34 over times 5 over 5 plus 32. That's going to be 202 pi over 5. Sweet. All right. So that's going to wrap it up, guys. This video was still pretty long, so I apologize, but we gotta do this. It's this. I'm not used to cramming so much information in a short amount of time, but I think it's the logic of it being a summer class that we unfortunately have to do this. So I apologize. Again, let me know if you have any questions, and I will see you all on the next one. Bye bye.